Hello, and welcome to a Science for Everyone video. At Science for Everyone, we strive to make science more understandable and accessible for all. I am Prachi Patel, and today we will be discussing statistics manipulations and how we can learn to spot them. So let's get started. What are statistics? Statistics are numbers or data that we collect from people and analyze to draw conclusions. Statistics are relied on often to make decisions. This could be as simple as someone deciding what cereal to buy, or at a larger scale, like governments establishing policies. Both depend equally on data to make informed decisions. Since data is used as a source of information, it is important to know that numbers can easily be manipulated to push certain agendas. Manipulated statistics are often used to spread misinformation as they look like they're credible information that is backing up the claim. However, it is important to remember that since the way the data has been presented is not accurate, the claims are actually not supported. So, how can data be manipulated? One way is by cherry-picking the data. So, instead of showing the entirety of the data to the public, a small portion of it that supports the claim is shown and everything else is ignored. Let's imagine you want to show that eating chocolate every day decreases the chance of headaches. You have data from 100 people who ate chocolate every day for a month. You see that in week 3, there were the least amount of headaches. So if you wanted people to believe your idea, you might just include this data to show that people who ate chocolate daily had fewer headaches than people who didn't eat chocolate every day. This would be cherry-picking your data. This is misleading and reduces the credibility of the research since it suggests the idea was supported when truly it was not. Well, what about in our everyday life? Where do we see cherry-picking occur? One example is when the Republicans in the USA questioned the use of Planned Parenthood in 2015. They used this graph with the intention to suggest that the funding given to Planned Parenthood needs to be changed. At first glance, it looks like the number of abortions has increased and the number of people getting cancer screening has plummeted. But now let's take a look at the actual numbers. Here it suggests that 935,573 is less than 327,000. That doesn't seem quite right. So, although the number of abortions has increased and the number of cancer screenings has decreased, it is not as amplified as this graph suggests. Let's take a look at a more accurate representation of this data. Here we can see that even though the number of cancer screenings has decreased, the number of people using the cancer screening services is still massively greater in comparison, almost 500,000 more people. Another thing to note is that the first graph was made by an anti-abortion group, so it is important to consider who is presenting the information and what their agenda is. Another way statistics can be manipulated is by skewing the way the data is presented on a graph. So to do this, you will see the vertical axis, also known as the y-axis, will not start at 0. This creates the illusion that the data has bigger differences between them than they actually do. Let's create a graph that shows the differences in the amount of sugar in a 100-gram piece of fruit. According to this version of the graph, where the y-axis, or the vertical axis, is beginning at 8 rather than 0, there appears to be a big difference between the amount of sugar in grapes and oranges. But if the graph were to change so that the axis actually started at 0, the amount of sugar appears to be relatively similar. Both of these graphs showed the exact same information, but one of them makes you believe that grapes have way more sugar than the rest of the fruits. So, how does this appear in actual life? Well, let's take a look at this example. In this graph, it suggests that Democrats agreed with the court about 3 times more than Republicans and independent candidates. The important thing to notice is that the graph's y-axis actually begins at 50%. Now, if we take a look at this second version of the graph, we see that the difference doesn't appear as vast as it did initially. The difference is actually of only 8%. So if a voter were to see the first graph, they may have drawn different conclusions about the parties than let's say someone who saw the second graph. Another thing to consider is the accuracy of the visuals. The graph or the image may imply one thing, but if the data is actually looked at, it would suggest the contrary. For example, in this pie chart, at first glance, it looks like most of the people voted yes to the question. But if we take a look at the percentage, only 35% of the people voted yes, while 65% said no. A more accurate chart would be this one, where the percent and the section of the pie actually match. Another thing to consider is if the right type of graph is used. In this example, the pie chart that shows the primary concerns people had about COVID-19. It appears that all three of the options have about equal chunk of the pie. However, if we look at the numbers, they add up to 178%. So for a pie chart to actually be meaningful, each of the pieces has to add up to 100% in total. So based on this graph, we actually can't draw any conclusions. The data seems to be meaningless. However, in this version of the graph where I use a bar graph, we can actually draw conclusions, like that 68% of the voters were worried about the economy. The choice of the graph can make the data that seem to be meaningless make sense. The next thing we'll talk about is missing axis titles. So, we've seen the effect of having a truncated y-axis, or where the y-axis is not starting at 0, but what about an axis that has not been labeled? Then our big concern becomes, how do you understand what the data is showing? If the title is missing, then the information can easily be manipulated to push a point. Someone can claim that this graph shows the amount of national debt, the amount spent by the government, or something silly as the amount of ice cream sold. The axis title gives context to what you're seeing. Without it, the information is also easily manipulated. How can data manipulation impact our lives? Data is used to make decisions. If we rely on faulty information, we will make the wrong decisions. We have often seen manipulated stats used in politics. This can affect who gets votes and who gets placed into a position of power. Politicians often rely on misinformation to lead their campaigns to victory. Another impact is how resources are allocated. Data is used to establish policies, so if the data is corrupted, then the policies enforced will be ineffective. During the COVID-19 pandemic, many countries manipulated their reported number of cases. This led to an unequal distribution of resources, like vaccines and medical equipment. This resulted in countries that had artificially increased the number of their cases receiving more resources than they needed, and the countries that were truly in need having deficiencies. So, what can we do about this issue? Stats manipulations will likely continue to exist, and it will actually be your job to learn how to spot them so you don't fall victim to their scams. Just like how you don't think you won a free cruise if an unknown number calls you to tell you that you won. But not so long ago, this was a very common scam. So how did this one decrease? Well, people started to question the logistics, and the number of people who were victimized dwindled. So similarly, you need to ask questions like, who's collecting the data and why? What's their agenda? Did the visuals of the graph make sense? Did the axis start at 0? Were the axes labeled? Was the right type of graph used? Did the data and the visuals actually match? Asking questions like these is the best way to protect yourself from falling victim to data manipulation. So, today we learned about statistics manipulations and how you can identify them. On behalf of the Science for Everyone team, thank you for watching.